Hello everybody, and welcome to my video explaining how the Molal freezing point depression formula works. You'll know when you have one of these problems when it says the Molal freezing point depression, or this little K of F. Now, the problem reads, how many kilograms of glycol dissolved in 3.55 kilograms of water are needed to lower the freezing point of water to negative 22 Celsius? They also give us the Molal freezing point constant, which is 1.86. Now, let's make a list of what we know and don't know, which is right here. We know that we have 3.55 kilograms of water, and that the new temp is negative 22 Celsius. We also know the constant, like I said. What we don't know is the kilograms, and that is what we're going to solve for. Now, the formula to solve one of these problems is right here. Delta T of F equals K of F times molality times Hoff's factor. Okay, now how are we going to arrive at this point? Well, first, let's see. We'll plug everything in. So first, how do we get our delta T? Well, that's easy. The normal freezing point of water is 0 Celsius. It goes down to negative 22 Celsius. Now, what is the number from here to here? It's going to be 22. You're going to have a change of 22, and that is going to take the place of delta T. The rest should be pretty easy, because now it's just fill in the blank. So if we look at our formula here, now we have delta T, it's 22 equals K of F, which we are also given, which is 1.86 times molality times Hoff's factor, which in this scenario is 1, since it's not an electrolyte. Now, the one number here we do not have is M for molality, and that is what we need to solve for. That's the key to this entire problem. Now, the formula for molality is equal to moles per solute divided by kilograms per solvent. Now, to get these moles, I'm going to pull out this little molar mass thing I derived from the periodic table. You can just get that if you have access to a periodic table. That's, easy as said. But now what you're going to do is basic algebra, and you're going to divide out this, and the 1 doesn't really matter because it's a 1, so you can just get rid of it if you want. But that's going to mean M is going to equal 22 divided by 1.86, or M is equal to 11.83. Okay, so now what do you do now that we have molality? Well, the rest is fairly simple. You're going to set up your own algebraic problem. So how do you do that? You take your molality formula and you take your moles of solute, which you don't have yet. So you just write moles of X if you would like, divided by kilograms of solvent, which you do have. And it is right here in the very beginning, 3.55 kilograms of water, which is your solvent. See something familiar? Kilograms of solvent. So you're just going to write 3.55 kg. And now that we have our molality, all you have to do is set this equal to your molality and solve, which obviously simple algebra will tell you just times it out. It'll get rid of it on this side. Those will cancel, and then it will go over to this side. And now all you gotta do is multiply those together, and you have your moles of X. So moles of C2H6O2 is equal to 41.99. Now back up to this little thing I pulled out earlier, right here. This is our molar mass. All you gotta do now is convert this 41.99 moles into grams. And now you have your almost finished answer. But we're not done yet. You gotta make sure that you fully finish this problem, or you will get it wrong on a test, because this is still in grams and it is asking for kilograms. So all we got to do is convert 2606.19 grams times 1 kilogram per every 1,000 grams. and that is your conversion factor, giving you 2.61 kilograms. And that, ladies and gentlemen, is how you solve a Molal freezing point depression. And it is fairly similar to how you solve a boiling point elevation constant formula problem. I know, still a mouthful, but you get the point. Thank you for watching. I hope it helped you, and if it didn't, please leave a comment below, and I can try to help you, one-on-one, or maybe I could put out another video that explains things a little bit better. But again, please, if you have any constructive feedback, do send it in the comments. Any questions, put them in the comments. But other than that, have an amazing night, and good luck on school, and good luck on your tests.